Today I'm going to show you how to do a chi-square goodness of fit test in R. We use chi-square goodness of fit test to compare the frequencies observed to a expected distribution of frequencies. For example, an independent assortment of genes, when you cross two dihybrid parents, the potential phenotypes of the offspring will sort to 9 to 3 to 3 to 1. Let's say we do a dihybrid cross and we take 100 offspring and we observed 30, 20, 20, 30. So we have 100 individuals. Does this frequency of phenotypes match the 9 to 3 to 3 to 1 expectation? So our expected is 9 over 16, 3 over 16, 3 over 16, and 1 over 16. And we multiply all of that by 100 because it's 100 individuals. And so our observed is 30, 20, 20, and 30, which adds up to 100. And our expected is 56.25, 18.75, 18.75, and 6.25, which add up to 100. The chi-square equation is the sum of our observed minus expected squared divided by the expected. And if we run that, we get a chi-square of 102.67. We know that our degrees of freedom equals the number of observations minus 1, so 4 minus 1, and of course that equals 3. We can go to the back of our book and look at a chi-square table to figure out our p-value, or we can have R calculated for us. It's simple. All we need to do is use the p chi-square function. Q equals our chi-square value, which is 102.67, and our degrees of freedom equals 3. We also want to make sure this is a one-tailed test, so lower tail equals false. If you notice, our p value is a lot less than 0.001. It's also a lot less than 0.05. Therefore, we can say that our null hypothesis, which is that our observations fall under 9 to 3 to 3 to 1, we reject the null hypothesis. We can also run the built-in R function for the chi-square, which is CHISQ.test. And we just need to add two things. We need to add our x, which is our observed, and we need to add our p, which here equals expected divided by 100. We divide by 100 because we just want the probabilities. The 9 over 16, 3 over 16, 3 over 16, and 1 over 16. We run that. And, as you can see, our chi-squared value is the same as the one we calculated. Degrees of freedom is correct, and our p-value is extremely small. And so we have calculated this both by hand and using the built-in function.